All right, so topic for this video, one-sided limits. And I would say that this topic is mainly about notation, okay? And what I mean by that is I don't think that the concept of a one-sided limit will seem that strange to you if you understood limits as we've already talked about them. Okay, so it's mainly just, it'll be a short video just to show you a little bit about the notation. I will do some problems also, but again, I don't think it will surprise you that much, okay? All right, so when you see something like this, limit x approaches 4, and the 4 has a superscript, meaning that's what looks like an exponent of a plus sign, then we read that as x approaches 4 from the right. And if you were to ever see limit x approaches 4, and again there's a superscript but it's a minus sign, then that says the limit x approaches 4 from the left. Okay? And you say left and right with respect to what? Well, the number line. On the number line, there's 4, and then numbers to the right of 4 are like 4.1 and 4.2, and numbers to the left of 4 is 3.9 or 3.8 or something like that. Okay? All right, so now you know the notation. Let's look at a few problems just to make sure everything's okay. So suppose I give you this function, and say for this we'll deal with a piecewise function. It says y is 2x squared if the x is less than 2. And y is 3x if the x is greater than or equal to 2. Okay? And I ask you, what's the limit as x approaches 2 from the right and from the left? And maybe just to review, just the limit as x approaches 2 as it is. Okay? Now, there are lots of ways you could think about this at this point. We've done plenty of tables and graphs, okay? So I know you've seen that before. And I'll supply you with this. It's like you could do this in your head too. It's like there are definitely people that can just look at that and you can say, well, where does that put you when you're close to 2? Well, what's 2 squared? 4, so 2 times 4 is 8. It'll put you about 8. And where's this going to put you when you're close to 2? Well, so 3 times 2 is 6. It'll put you about 6, okay? And so you could determine the limits based on that alone. But if you want the numbers in the graph, then go for it. Okay, there it is. So here, into this function, when I put numbers less than 2, they go into that formula, and that's how I got all these. And here's some numbers to the right of 2, and numbers bigger than 2 go in this formula. And so that's how I got all these. So let's do this one first. Let's do the limit as x approaches 2. What would you say the limit as x approaches 2 is? Well, does it look like, here's what we said in the past about this. Does it look like these are going to meet in the middle? Here, this is headed to 8, it looks like, and this is headed to 6. It doesn't look like they're going to meet in the middle to me. Or we said if the graph had a break, what's called a jump discontinuity, at 2, that would mean that the limit as x goes to 2 does not exist. So either way you look at it, okay, by the table or the graph, you can tell that the limit does not exist as x goes to 2, okay? Do you need the table? No, those are nice tools. It gives you something to think about. It gives me a way to explain it. It's tangible. You can see it. But that puts you at about 8 near 2, and this puts you about 6. How are they going to meet in the middle? Okay. All right. Now, what about the one-sided limits, though? What's the limit as x goes to 2 from the right? Well, okay, so here's the numbers right of 2. As we get closer and closer and closer to 2 from the right, here's the right, the y gets closer and closer and closer to 6. If you were to look at this graph that I drew of that function, then here are the numbers right of 2. They're going to give you y coordinates right above, just barely above 6, just like you see in the table. The table and the graph is the same thing. So the limit as x goes to 2 from the right, that will be 6. And the limit as x goes to 2 from the left, well, okay, these are the numbers less than 2, left of 2, closer and closer and closer to 2. For x gets you closer and closer and closer to 8 for y. And sure enough, on the graph, we see the same thing. The numbers left of 2 are here. They take you up to this part of the curve, giving you points just beneath the 8, just like you see on the table. Okay, so there 8 is our limit on the left. Okay, so you got the right-hand limit, the left-hand limit, and just the limit, okay? Now, one more fact about this is if these were ever different, this one would always does not exist, okay? All right, so keep that in mind. Let's look at one more. So I wanted a similar question, but let's say this piecewise function has 3 parts, okay? All right, so 3 minus x if x is less than 2. Y is 3 minus x if x is less than negative 2. Y is 2x plus 9 if x is more than negative 2. And notice how both of these leave the 2 out. And then y is 1 if x is 2. All right? Okay. Now, what I notice about this is that this one picks up at where this one leaves off at. Where does this put you when you're close to negative 2? Well, what's 3 minus negative 2? 5. So when you're close to negative 2, you'd think that this would put you at about 5. Where does this put you at negative 2? Also 5. Where do you think this is going to put you when you're close to negative 2? It's also going to put you close to 5. So on my graph, you can tell that they do meet in the middle at 5. Okay? I drew the graph. I sketched this line less than 2, this one more than 2. There's a hole there because neither of these include negative 2. And then what? Y is 1 if x is 2. That would be this point at negative 2 for x. Oh, I meant to put negative 2. That should say negative 2 right there. Sorry. Negative 2 for x gives you 1 for y. All right. Okay, so here goes then. Let's do the limits. Then I would say this time the limit as x goes to negative 2 altogether. Well, do these look like they're going to meet in the middle as I push the x closer to negative 2 from either side? It looks like they're going to meet in the middle at 5. So yeah, so 5. There we go. The limit as x goes to approaches negative 2, f of x is 5. Look at my table. Look at my graph. Any x close to negative 2 puts you near 5 either way. All right. What about x goes to negative 2 from the left? Well, here are the numbers left of negative 2 on the number line. And yeah, the closer they get to negative 2 from the left, the closer the y gets to 5. That's the left. On the right, the closer that the x's get to negative 2 from the right, the closer the y also gets to 5. So our left hand and our right hand limits are going to agree with each other. And so that if the limit as x approaches negative 2 has an answer, the left and the right hand limits will be the same. Okay? All right, because why is that true? Well, whenever I initially did this for you, like when we first learned about it and I made tables, I would say if it looks like these are going to meet in the middle, it looks like from either side they're headed to the same place, that will be the limit, whatever that spot is, 5 in my case. Well, that's like when you look on the left and right, you're seeing the same progression. Okay? Table and the graph say the same thing. Now, I'll leave you with this though. See that point there? See the fact that y is 1 if x is negative 2? Does that influence any of these limits? Does it influence the limit as x approaches negative 2? Well, I've said before that that's an arrow. I want to see what happens, what the pattern is, what the cause and effect is as x approaches negative 2. The question of what happens if x is negative 2 is besides the point. And if that's what we wanted to know, that wouldn't be an arrow, right? So no, this point here does not influence any of these limits at all, okay?